Let's have a look at the first one first. Look at the first one. When we run this code, the result is A, B, C, D, F, H, I. So what we are doing is iterating through each item inside this sequence. So here, for X in sequence means X becomes ABC in the first iteration, and in the next iteration, it's going to be DF and G and HI. All right. Then X, when it is ABC, has the length larger than 1, so it is going to be processed. And for Y in X means it's going to separate each character inside X. So in the first iteration, X is ABC, and Y becomes A and B and C. All right, so that's why A, B, C appears here. And in the next iteration, X becomes DF because X is iterating through the sequence list. And when X becomes DF, it is here, and Y becomes D and E and F. And when Y becomes E, it is not included in this list. So that's why D and F, skipping E, appears here. And G, because it has the length not larger than 1, it is here. And HI also gets separated like this. All right. And sorry for that. And for these practice questions, I'm going to solve the first 2 questions with you. And you can think about these 3 other problems on your own after class, okay? So let's talk about the first, sorry for this one. All right, the first question is quite easy. So for question 1, the answer is we're going to select a number n for n in range 1 through 101 because we want to check numbers from 1 to 100. And we are skipping the last one. We do not include the last one indicated here. If n percent 7 equals 0, this means n is divisible by 7. Okay. And the second question is same as the first one, like this. And this condition might be somewhat confusing at first. And what we can do is, there are many other ways, but we can convert this number into string and check whether 3 is inside this string or not, okay? So this is what we learned in the last class. All right, so up to this point, we talked about lists and list comprehension. And another type of containers is dictionaries. So from now on, I'm going to talk about dictionaries. So what are dictionaries? I'll show you some examples. Let's say in the case of list, we just contain some numbers in a sequence or some items in a sequence. And when it comes to dictionaries, we have 2 entities. dog and fox, like this. So in the case of dictionary, we have keys and item, like this. So we have a list of key and item, key 2, item 2, like this. So when we want to access to, so we are basically storing some pairs of items. So this is different from list. It does not have 2 things in one position, but this one in one position, we have 2 entities, key and item. So when we want to access some items inside this list, we access these items through key, okay? The item stored at the key cat is 1. And the item stored with the key dog is 2, all right? However, you need to be careful with this one because we cannot access to an item by the item itself, all right? It says there is no key such as 2, all right? So when you want to access to some items inside this dictionary, you need to access through keys rather than the items itself. So be careful about this. And after we define this dictionary, we can update or remove some items from dictionaries. Let me show you how to do this. So let's say I want to enter another item pair called fish and a number 4. Then now in our list, fish is added. Okay. And we can also use this get method or function, and we enter this key, and it will return the item belongs to this key, which is 4. Okay. And sometimes we want to avoid incurring some errors. And we want to retrieve an item, monkey. However, there is nothing related to monkey in this dictionary. Then in this case, if we use get, it will return none. All right. And another fun thing we can do is if we pass default, then it will return default if there is nothing related to monkey. All right. So when we access to this dictionary with this monkey item, it will incur an error, right? But this one avoids errors. All right. And so if there is no monkey, then it will return default. All right. Let's see another example. And what happens if we pass fish here? Then it will return 4 because fish is one of the keys inside this dictionary. All right. And we can do other things like len. Then it will return the number of items or pairs of items inside this dictionary, like this 4. All right. So this is dictionary. And there are also other functionalities of dictionaries. Let's say numerals, define another list like this. And I told you that this len function returns the number of pairs inside this dictionary. And we can also retrieve the values from this list like this. Using this values function, and then you can call this list and it will become a list. All right, so now it removes these keys or returns the items 1, 5, 10 like this. Okay. And are there any ways to create dictionaries, something like list like this, as we did in list? Yes, we can create a list as it did for list like this. You can call dict like this. So you just pass a list of pairs of items, then it will become a dictionary if you call this one. Okay. And from up to this point, we talked about how we can create a dictionary and how we can add some items to these dictionaries. And how can it delete some items from a dictionary? That is using this del operation. So from this, so if we call del ddd1, this will remove the pair belongs to this key one. All right, so this one is removed and the rest remains here. So using this del operation is to remove some pairs of items inside a dictionary. Okay. So this was pretty much about dictionary. And we can also do the same dictionary comprehension. As we did for lists, like this. Let's say we have some numbers like this. We can create a dictionary like this. So this one corresponds to index or key, and this one corresponds to the item. All right. So we are iterating through the numbers inside this nums list. And if we filter out if this number is even or odd, all right, we only keep the odd numbers, even numbers, and then square them. All right. So the remaining one are going to be 0 to 4. So they are going to be the keys to this dictionary, and the items inside are going to be squared of the keys. Okay, so we can do the same thing as we did for list. So we can do dictionary comprehension. So you better understand these comprehensions thoroughly. All right, that was about dictionaries. Are there any questions up to this point? So today we are talking about containers that Python provides. And we talked about list and dictionaries. If there is no question, I'll continue.
그 아까 전에 list comprehension 마지막에 주셨던 exercise에서
Yep.
질문을 드리고 싶은 게 하나 있습니다.
Yep.
거기서 처리된 순서가 A, B, C 담고 D, F 담고 H, I 담고 그 다음에 가서 각각을 A, B, C 이렇게 알파벳 단위로 분리를 하는 건지, 아니면 A, B, C 담고 알파벳 단위로 분리하고 그다음에 df 담고 알파벳 단위로 분리하고 이런 순서로 되는 건지 여쭤보고
That's,
싶습니다.
yeah, that is a good question. This one is like this. Now, can you understand this part? So this one is equivalent to this code block. All right, think about it after class, okay?
감사합니다.
All right, let's move on. And another containers that Python provides is called set. As you can imagine, set is very similar to lists. However, sets do not consider the order of items. Let's talk about what that means. Let's say we have a set like this. So for dictionaries, we use these curly braces. And for sets, we use the same curly braces like this. However, when it comes to dictionaries, we present a pair of items, like key and item pairs. But for sets, we just list the items without keys. So that is the difference, right? So it could be confusing at the first glance. However, they are different. You just provide one item, all right? And we can check if cat is inside these animals, and it will return true, all right? And we can also check whether fish is in animals, like this, then it will return false because there is no fish in this set, all right? And when you want to sum items to this set, you can just call this add function. Then it will add fish here. You can also call this len function. And it will say this set contains 3 items, all right? And when you want to remove some items from this set, you can call this remove function and indicate what you want to remove. Okay, so cat is removed from set. All right, and we can do the same list comprehension for sets. So that is called set comprehension. So that is very easy. Here, not worry about this part. I just want to use this square root. Let's say I want to find out the square root of some numbers like this. And I will fill out 1, 2, 3, 4, 5. All right, can you guys understand this part? This is not that difficult. And when you want to iterate through the items, you can basically do the same thing as you did for lists. So iteration through the items inside this set is very similar to what we did for list, all right? And there was a question for dictionary, do item and value refer to the same thing? Yeah, they refer to the same thing. So basically, if you understood lists very well, then dictionaries and sets are very simple, all right? Okay. And for the last containers we're going to talk about in this class is called tuples. Some people read it tuple and others read it tuples, whatever is okay. Anyway, let's talk about tuples. One important aspect about tuples is that it's immutable. That means once you define a tuple, you cannot change the values inside this tuple. All right. I'm going to talk about what immutable means in more detail. All right. Tuple is basically defined by these two parentheses. Okay. And you can access to the items of this tuple using these brackets. Okay. And when you try to change the value of this value, then it will incur an error. Because once you define a tuple, you cannot change the values inside. So this one is why it is called an immutable data structure. And why do we need this kind of immutable data structures? Can you guys guess? Yeah, one suggestion was to store some default values. Tuples or immutable data structures are to store very important values. So for example, yeah, to prevent overriding is another good answer. So we do not want to change these values. So for example, let's say we want to store pi. And this number does not change, right? But if we define it as a number, then other people can change this value as 5, like this, in other parts of code. However, if you define it as a tuple, like this, then other people cannot change the value of pi in other parts of our program. All right? So Sebin gave a good answer. We cannot redefine tuples. Once we define this tuple, then it is just there. So it is for storing unchangeable values, all right? Like for example, some constant numbers like pi or birthday of some other people, all right? The immutable data structures are to store very important or sensitive values. Sensitive. So in one part of your program, you define some variables as tuples, then other programmers cannot change these values, okay? All right, so up to this point, we talked about some containers provided by Python, list, dictionaries, sets, and tuples. Okay, so for other containers, we could change the values inside. However, for tuples, we cannot change the values inside. All right. And there was another question. When it comes to remove, we can call the same remove for list and set. Even though they have the same names, they are different functions. All right. Eugene, does it answer your question? All right. So from now on, we're going to talk about functions of Python. Why do we define functions? Because we do not want to repeat the same functionality again and again. So so this is to make our code concise or simple as possible. And defining function comes with this def keyword. And here, so basically def and function name follows here. And you open a parenthesis like this and receive or denote the parameters and use colon here and then do something. So basically this is the structure of defining a function. Okay. So for example, let's implement a sign function that determines the sign of this number. So if x is larger than 0, it returns positive. And here, you can define a return value. So after calling this function, it will return some values. I'll show you what this means in more detail. If x is smaller than 0, it returns negative. Else, it returns 0. All right. So for x in -1, 0, and 1. So it will say negative, 0, and positive. All right. So this one returns positive, a string positive, and stores the value inside this variable result. So when we print out results, it will become positive, right? However, function does not necessarily have to return some values, all right? You can just print positive and don't have to return some values. Okay, so in that case, let's have a look at what this results. So in this case, the sign function does not return anything. And I told you that nothing in Python is represented by this none object. So it returns none after printing out this negative, positive, or 0. So none appears here, okay? And another thing we can do with functions in Python is passing some default optional parameters like this. So let's say if you want to make it loud, you can print hello capital. Else. So if we just pass the some values here, then it could be false if we do not pass anything. So let's say so for this function, we do not pass the loud value. In that case, is false because this is the default value. However, if we denote that loud is true, then it becomes true. Okay, so we can choose to pass this variable parameter or not. Okay. All right. And I would like to give you one exercise. Try to predict the result of running this code block. Think about it.